With both Google and OpenAI embracing Anthropic's MCP communication protocol, a lot of people are asking, what is MCP and why does it matter? In this video, I'm breaking it down in simple terms. MCP is quietly changing the way AI agents and language models connect to real-world tools like databases and APIs without the need for hard-coded integrations. MCP stands for Model Context Protocol. It's a communication standard that lets AI models talk to tools, APIs, databases, and files without hard-coding every single interaction. Instead of tossing in one-off API calls, MCP gives you structured, modular, and reusable way to connect tools to the model. To make it all work, you need something called an MCP server. Think of this server as a bridge between the language model and external tools like Outlook, Google Calendar, Maps, Expedia, or Canva. For example, MCP Server A might manage calendar functionality using Outlook or Google Calendar. MCP Server B might handle travel bookings through Expedia or Kayak. Here's the cool part. These MCP servers don't have to be built in-house. They can be hosted by third-party providers like Microsoft, Google, Amazon, or Apple. So your AI agents might talk to Google Calendar via one MCP server and use Microsoft Teams via another. As long as they follow the MCP format, it's a plug-and-play. Here's where MCP really shines. Let's say your company uses Expedia today, but switches to Kayak tomorrow. No problem. Just plug Kayak into the same MCP interface, and as long as both tools follow the MCP schema, it just works. Same thing with calendars. Outlook today, Google Calendar tomorrow, minimal refactoring. It's like using a universal power adapter for AI tools. If the tool speaks MCP, the AI agent just keeps working. Let's walk through a quick real-world example. A user types, "Book me a flight to Toronto next Thursday and find time in my calendar to meet with Sam on Friday." That message hits the chatbot app. The chatbot forwards it to the LLM, along with a list of available tools from both MCP servers. Now, here's where things get powerful. The LLM understands the request and selects the right tool on its own. It chooses Search Flight tool from the Travel MCP server and the Check Availability tool from the Calendar MCP server. Why? Because the tools are described in a structured format with names, descriptions, and parameters the model can reason over them natively. No need to hardcode logic like if user mentions flights, use Expedia. The LLM figures it out automatically. Each MCP server handles the actual execution. MCP Server A talks to the Calendar API. MCP Server B talks to the Flights API. Then, each server returns a structured response. Sam is free Friday at 2 p.m. There is a flight to Toronto on Thursday at 9:30 a.m. The LLM takes that info and crafts a response. I found a flight to Toronto Thursday at 9:30 a.m. and Sam is free at 2 p.m. Want me to go ahead and book them both? That's the magic. The LLM is smart, but the MCP infrastructure makes it productive. And this isn't just about travel. MCP gives you the architecture to build AI agents that talk to dozens of tools, custom copilots that understand your workflows, multimodal bots that work across text, data, and files. It decouples your business logic from the AI layer and lets you treat tools as modular, swappable components. MCP is early, but it's a game changer. It's the difference between prompt hats and robust and intelligent systems. If you're building with GPT, Claude, Gemini, or LLaMA, understanding MCP will help you future-proof your architecture. If you found this helpful, drop a like, leave a comment, and subscribe for more breakdowns like this.